Now, my name is Michael Levan. I'm a published author. I'm a consultant. I speak at conferences like this or meetups like this, also at conferences and all that good stuff. And on top of the content that I do, whether it's stuff like this, whether it's writing books, blogs, videos, etc., I also consult. And what that means is I am still, writing production code. I'm still working on production environments for clients. So typically, my consulting will usually fall under like the, hey, we want to get our Kubernetes environment up and running for the first time, can you help us throughout the whole process? Or it'll be something along the lines of, hey, we're trying to migrate, or we're trying to do things differently, or whatever the case may be. Now, the reason why I bring that up is because I want to make it clear that the stuff that I'm talking about today isn't just based on like, hey, these are the products that I like. This is the stuff based on like, this is what I would give particular clients, right? Like, this is the stuff that I would use. These are the products that I would use for clients. Excuse me one second. I just need to clear my throat here. All right. So I'm going to be talking about 10 standard practices that I would typically use, right? 9 or 10 standard practices when thinking about production Kubernetes, right? And one of the things that I'll do after this is I have a very short ebook. I think it's like 20 to 30 pages or something like that. It's available on Gumroad, but what I'm going to do is I'm going to export the PDF and I'm going to give it to Christina, so Christina can give it to everybody at the meetup for free. It's very short, but it's one of those things where you would take it and you would just like, kind of put it on the side, of your desk, and you would just flip through it and be like, oh, okay, this is how I do that thing, right? It's more of like a little guide, right? A little hand guide there for you. So first things first is liveness and readiness probes. Now, liveness probes are going to determine if your pod is healthy. Readiness probes are going to define or determine rather if a pod is ready to accept requests, right? Because a pod can be up and running and be healthy and up, but perhaps the application or the container rather inside of it is not healthy. So there could be something where, and I've seen this a ton, where it's like, yeah, the pod is up and running, but the application inside of the pod is not working as expected, right? And that's where liveness and readiness probes would come into play. So another thing that liveness probes do is they determine if a pod is running as expected, right? Whereas again, this comes down to like okay, is it doing what it's supposed to be doing, right? And that's a big thing. And we could even take it back to VMware days where it's like, okay, the virtual machine is up and running, right? But it's like, is it doing what it's supposed to be doing? And then that's, there's a big difference between the thing is up versus is the thing doing what it's supposed to be doing, right? And the kubelet, which is the agent sitting on the worker nodes, this is where this comes into play as well. So the kubelet uses the liveness probes to know when it should restart a container inside of a pod. And then for readiness probes, the kubelet uses the readiness probe to know when it should start accepting traffic, right? So again, liveness probes, is my pod running as expected? Readiness probes, is the pod ready to accept requests? Is it ready to accept traffic? All that, right? Ingress traffic. All right, now let's kind of take a step back and talk about namespaces for a second in terms of segregating resources. So namespaces are great if you want to take a particular stack and kind of give it a home, right? You're going to give it a place to live. It's not meant for security purposes. It's not meant to like take application stacks and segregate them from each other from a security perspective of, ingress, egress, who has permissions, et cetera, to access the different pods. That's not what namespaces are for. Namespaces are to take a collection of resources, right? Kubernetes resources and an application stack, and just kind of give it its own little place, right? I like namespaces because number one, you don't just want to throw everything in the default namespace. Number two, you do want the ability to control who has access to what in the namespace and also control what traffic can go where, right? So like when we're thinking about access control in a namespace, we can attach it to certain service accounts, we can attach it to certain RBAC permissions. On the other side of it, you have the application stack and what it's able to talk to in other namespaces. And that's where something like network policies would come into play, right? So when we're thinking about namespaces, think segregating resources, but not from a security perspective, just from a collection perspective. You're putting it into its own little home, right? The next thing is auto scaling. So you have scaling your infrastructure and your apps, right? And these are two very, very different things. And you're going to set them up in two very different ways, especially, depending on where and how you are deploying. So when you're thinking about scaling your infrastructure, let's say you're on prem, well, you're going to be thinking about something like hot cold environments, right? Where you have worker nodes kind of on standby and ready to get deployed. In the cloud, it's pretty straightforward. You're just going to kind of turn on auto scaling, right? You're going to flip the switch, and if more worker nodes are needed, they're going to come up. If they're no longer needed, they're going to go down. Now, from an application perspective, you want to ensure that you're setting your minimum counts, you're setting your max counts for your replica sets, right? So maybe the minimum is 2 replicas and maybe the max is 10 replicas, right? Depending on your quotas, your limits, and your requests, which is again another big piece of your auto scaling. You can have as many pods as you want, but guess what? If you don't have proper quotas in place, if you don't have proper limits in place for, your memory, if you don't have proper requests in place for your CPU and your memory, you're going to run into a circumstance where the pods just will not start because they don't have enough resources on the worker nodes. Now, again, this is where having proper scalable infrastructure comes into play for your worker nodes. But at the same time, you want to make sure that your containerized applications aren't just taking megs and megs or gigs and gigs of memory, right? Like, because it may not need it. And, that may be an issue with the application or whatever the case may be. But ultimately, you want to be able to control your resource consumption, and you want to be able to understand and see your resource consumption at a much deeper level. And again, this is the same thing we did with virtual machines. I'm assuming a few folks here that are listening, we're in, data centers with ESXi or with Hyper-V, whatever you decided to choose for your hypervisor. And it was the same thing. You could have a bunch of virtual machines running on a server, but if that server ran out of memory, if it ran out of CPU, guess what? The virtual machines would crash. They would not come up as expected, et cetera. Same exact concept here, right? So auto scaling is going to be a big piece. Next, you want to make sure the APIs that you're using are as expected. So you want to make sure that you're thinking about the Kubernetes API, right? Or the version of Kubernetes, right? 1.24, 1.25, et cetera. You want to make sure that you're upgrading as expected. You want to make sure that you're watching out for bugs. You want to make sure that you're watching out for security issues with the APIs, et cetera. A really good example of this is after 1.25 of Kubernetes, pod security policies or PSP are no longer there. They're not even deprecated. They're just completely removed. So your policy enforcement, if that's the case, and when you're upgrading, you have to think, oh, now I need to move to, Open Policy Agent or OPA, for example. So things like that, you want to make sure that you understand what's deployed in your environment, and you want to make sure what's there and what's not there. Again, the example there are pod security policies. The next thing is the actual APIs for the Kubernetes resources themselves, right? So you have your core API group, and then you have your named API group. And your named API group, those are all the new APIs. And those things are changing. Like I'm sure everybody here has seen, in a Kubernetes manifest with the version, right, /alpha/beta, right? You want to keep an eye on those things because once they graduate out of that alpha phase or out of that beta phase and into the V1 phase, you're going to have to upgrade things on your end as well, right? So APIs, understanding what's running for those APIs, understanding the upgrade paths, understanding how it changes the way that you're running your environments, very, very crucial to understand. Security, right? Security is a big piece, and security, the planning of security often comes in the day zero piece. Christina and I have a great podcast coming out. Don't know when. Soon though. It's gonna be on Kubernetes Unpacked on the Packet Pushers Network, and we're talking a lot about security in that one, and a lot about day zero, right? And thinking about security planning. And then we're thinking about the day two piece of the actual implementation, right? So Once your cluster is up and running, and when you're ready to start deploying applications, you have to think, who needs access to these namespaces? Who needs access to these pods? Does everybody need write access? Probably not. Does everybody need read access? Maybe, depending on the person, depending on the circumstance, depending on what the engineer's job is. And then there's the other piece of service accounts. When you have a service account that you're deploying Kubernetes resources with, you have to think, what does this service account actually need access to? That's a very big entry point for whatever we want to call it, attackers, right? Red team and all of those other fun buzzwords. Um, that is a big entry point for them, right? A compromised service account with improper RBAC rules, right? So there are a few different things that we can use to kind of fix this. CIS benchmarks for Kubernetes, fantastic resource. Scanning the clusters, whether you're using Kubescape, whether you're using Kubebench. I think Aqua Security has a bunch of other scanning tools as well, if I'm not mistaken. So there's a bunch of different options out there to scan your cluster, to scan the pods, to scan the Kubernetes manifest. Checkoff is another one, right? So like there's a bunch of different resources out there that you can utilize to scan everything and make sure that everything's on the up and up. And one of the things that I definitely recommend 100% is, and you know what, I'll show it here. I think I have the newest CIS benchmark on my desktop. But CIS benchmarks for Kubernetes, and they're free. All you have to do is just Google CIS benchmarks for Kubernetes. It's going to make you put in your first name and your last name and your email and yada yada, right? Because they want to they want to get you on the list. But after that's done, you can download the reports and stuff for free. So that's a really good one. And then of course, you have your authentication piece, which is different from your RBAC, right? Your RBAC is your permissions or your authorization, and then your sign in is your authentication. Now, certain OIDC solutions, right? OpenID Connect solutions, they have both. Give you an example, Azure Active Directory, which we'll take a look at. Azure Active Directory is going to have both. It's going to have your authentication piece, and it's also going to have your authorization piece. All right. And then, of course, there's Kubernetes secrets, but the best practice at this point is to not use them. The reason why is because Kubernetes secrets are stored as plain text, base 64, with the OPAC default standard. So what that means is if you have access to etcd, you can see those secrets very easily, right? Just in plain text. So what I'm seeing oftentimes for secrets and what I'm implementing for clients usually is HashiCorp Vault. There are other solutions out there as well, but HashiCorp, like when I'm implementing a solution for a client, I'm looking at not the latest and greatest, right? I'm looking at what's good right now, but really what I'm looking at is how is the support? How's the documentation? Is my client going to be able to figure this thing out when I'm gone 6 months later type of deal? So I'm always looking at the new thing, but ultimately, like, is it steady, right? Like, does it have good documentation? Does it have good support? Are others implementing it? Because as we all know, there's a big difference from an engineering perspective between what's the hot new thing and what's actually practical for a production level environment, right? All right, so then you have monitoring and observability, right? And monitoring and observability, you're going to see a lot of tools that kind of just like throw them into the same category, which I believe is incorrect. Monitoring is about seeing the data, and observability is about doing something with the data, right? So monitoring is going to say, okay, I have these cute, pretty graphs in front of me, and I see my memory and my CPU going like this, and it's making me understand what's happening in my environment. And observability is, uh-oh, something's wrong, kick into action, run some run book, right? Let somebody know, whatever the case may be. Like any automated approach, right? Observability equals doing something with the data, monitoring equals seeing the data. Now again, these are typically jumbled up in a lot of different products. I also know people that disagree with me between the definitions between monitoring and observability. If you are one of those people, that is perfectly fine. This is just my opinion on what monitoring and observability looks like. But ultimately, what we want to think about is if you're not running a managed Kubernetes service, if you got a bootstrap cluster with kubeadm or something like that, you want to make sure that you're monitoring your control planes. And then, of course, you want to make sure that you're monitoring your worker nodes either way. Now, there's a caveat here. Oftentimes, when you're using a managed Kubernetes service, AKS, EKS, GKE, whichever other ones, right? A lot of people think I don't have to know what's happening in my control plane. Here's the thing, you still do, right? You still need to know what's happening inside of your control plane. You need to understand, I'll give you a perfect example. When you're spinning up an EKS cluster, you have logging options for the control plane. You don't have access to the control plane. However, you know what you do have? You have audit logs. So yes, you don't have access to the control plane, but guess what? You have access enough to the control plane to see who's authenticating to your Kubernetes cluster. And guess what? If somebody that's not supposed to, or an attack that's not supposed to be happening, obviously, right? You're able to get that data. So you still need to monitor and observe your control plane, right? And again, a perfect example of that is collecting audit logs. And for applications, it's obviously the same thing, right? Like you want to be able to monitor and you want to be able to observe containers running in pods themselves, make sure that they're scaling properly, make sure that none of them are pending. All very, very important pieces here to the Kubernetes pie. All right, what do we have? We have a few more things and then we're going to jump into the demo. Don't worry. Let me see. Yep. Okay, so proper networking, same thing. You have your pod networking and then you have your cluster networking. These are two separate networks. You have your cluster network, which is, running your Kubernetes cluster, and then you have your internal pod network. So if you have your container network interfaces, your CNIs. You have, the IP addresses that are attached to your pods it's in a completely different network than what's attached to your Kubernetes cluster itself. So you definitely want to keep that in mind. Even if you're running a managed Kubernetes service, you can use the default CNI, but now, like for example, AKS recently released in beta the ability to use Cilium, which is Cilium and Calico are usually my go-to CNIs because they're very security centric. They allow you to like encrypt traffic, going back and forth instead of using service mesh and all that good stuff. So understanding how you want your network to look inside and outside of your cluster are two very different things. Typically in like standard network environments, right? If you've ever been an infrastructure engineer or a network admin and worked in a data center, those days still are, right? But those days that a lot of us were doing it, we often saw very flat networks. So like, you had your firewalls and your routers and your switches and, your IDS systems and your IPS systems, and they would kind of sit there outside, right? But what was happening inside the VMs, for example, was very flat, right? With pod networking, it's different because you have policy enforcement, you have network policies, you have the ability to encrypt traffic from one pod to another, from one service to another. So proper networking is obviously a big crucial thing here. Next, you want to make the process as repeatable as possible, right? So there is a difference between automation and repeatability, right? I can write a bash script, I can write a Python script, I can write a Go script to go and do anything for me, a PowerShell script, whatever, to go and to perform any action for me that I want. But oftentimes I have to think to myself, like, is this repeatable? Can the other people on the team do it? Does this code grow in a way that I have to constantly maintain it and constantly check it? Or is it just kind of organic in the environment because all the other teams are doing it as well? I always use the example of, X amount of years ago, for the company that I was working for, I was like the only one that liked Go. Everybody else wanted to use Python. I was like, well, we should use Go because of this and that. And the next thing, really, what it came down to is I just enjoyed Go more than other languages. And that was the problem, right? Because if we implemented Go and I was the only one that could use Go and I left or I was on vacation or whatever, that makes it no longer a repeatable process because others cannot use it. So it's very easy to automate something. It's a little bit harder to actually make it truly repeatable. So make sure that you're doing that for your clusters. From an automation and repeatability perspective of deploying pods and deploying containerized applications, I would say at this point, it is safe to say that GitOps is the current standard. Now, if you're not familiar with GitOps, there's a lot of information about it out there. I teach a live O'Reilly course or O'Reilly class every couple of months where we're going through a bunch of GitOps stuff and setting it up and all that. But GitOps is pretty much configuration management, right? It's to confirm that the current state of your cluster is the desired state, to confirm that the code that's in your Kubernetes manifests are deployed as expected to your Kubernetes cluster. So if you're not familiar with GitOps, when you're thinking about GitOps, think configuration management. All right. And then you have your testing. Now, again, this goes back to what we were talking about from a security perspective before. You got your policy enforcement, you got your cluster scanning, scan your container images, scan your Kubernetes manifest. Yes, scan your Kubernetes manifest. Regardless of if it's YAML or JSON, code is code. Mistakes happen, bugs are there, security holes are found. Scan your Kubernetes manifest. All right, and one more here. Now, backing up and storing data. So this isn't talked about enough, I feel like, in the Kubernetes space. When you're thinking about backups, right? Like one of the biggest things that come to mind are volumes. So if you have pods that have volumes, guess what? You need to back those things up. You need to back up those volumes regardless of where they are. If you have an on-prem Kubernetes cluster and you're not backing up etcd, and if something happens to etcd, you're in big trouble, right? That's the brain to your Kubernetes cluster. Without etcd, you're up the river without a paddle. So backing up, storing data, testing your DR policies and all that for Kubernetes is incredibly crucial. All right, so I think that's the end here. Cool. And then now I'm gonna go ahead and share my screen. Just want to make sure I got no messages or anything here. Nope, I'm all good. Beautiful. All right, so now what I'm going to do is I'm going to share a little bit of code and a little bit of different things that we kind of talked about and a quick walkthrough of these things. I think I'm going to do my entire screen. I think that should be okay. Okay, cool. Yes, it's working as expected. Beautifully. All right, cool. So first things first, let's go ahead and talk about RBAC. Now, I had to pick a cloud to go with. I chose Azure because I think there's a lot of perhaps there's a lot of Azure folks in here. So chose Azure as just a good base, right, for this. So let's talk about RBAC. Now, luckily, Microsoft has Active Directory, and that's been the RBAC and authentication solution for a very long time for a lot of enterprises going back years, right? And Azure AD is awesome. And it's very awesome when it comes to Kubernetes. So I'm going to go ahead and I'm going to zoom in here a bit. I'm going to go to my Kubernetes service, and I have my AKS cluster here. I'm going to go ahead and I'm going to click on that AKS cluster. I'm going to show you how to do this with code. Don't worry. I just want to show you the manual way first. I'm going to go to access control. Now from here, I can click add and click role assignment. Now the cool thing is there's a bunch of RBAC roles already built in, right? So we have reader. What is this one? Listing cluster admin credentials for the cluster, grants access to read and write for Azure Kubernetes Service Cluster, right? So there's a bunch of stuff. So let's say we want to choose reader. Well, once you choose like just one of them, right? You click on any of them, you're going to see this little button here for members. Now at this point, I can choose whoever I want. Maybe this Pearson user here, right? And I'm going to click select, and then I'm going to click review and assign, right? Now, what I just did very quickly was, number one, I used the built-in OIDC provider, right, which is Azure Active Directory, and I was able to take somebody and give them access to this Kubernetes cluster. Now, if you don't have Azure and you have AWS, for example, and you still want to use Azure Active Directory, you absolutely can. You can use Azure Active Directory for AWS and GCP. Is it harder to set up than what I just showed you? Absolutely 100%. Is it doable? Absolutely 100%. So Azure Active Directory is a great implementation for OIDC. And the reason why I say that is because Active Directory has just been around for such a long time. Like they hit the nail on the head when it comes to authentication and authorization. So if you got it, I would say use it. Now we can also do this. Let me go ahead and zoom in here a bit. We can also do this in code, right? So, and by the way, this Git repo, I'm going to send it out to everybody afterwards. Everything that I'm showing on my screen, I wrote all the instructions and all the code down on how to get it up and running. So you'll be good there. All right. So with code, what you can do is you can run the AZ AKS show command, and then that's just gonna you're gonna use a query to get your cluster ID, right? Pop it into a variable, right? Next, you're gonna create an AD user. So for example, I use the Pearson user. You can go ahead and create one, right? And then finally, you're just gonna run the AZ role assignment create command, and then you're going to take that username and you're gonna pop it into your AKS cluster, and you're gonna give it a certain role, right? Or the person rather, a certain role, right? Now, the next thing is scaling, right? So what is it under? Yeah, node pools. All right. So if I go to node pools here, you can have a few options. So you see here how I have a default node pool. There's 2 nodes running. Now, if I click on it, I can do a few things. I can scale the node pool. Now I have 2 options. Manual, so I can change it here, and the maximum node count you can select is 5 because of my remaining quota on my Azure account. But as you can see, you can kind of go, I don't know why you would want 1,000 nodes on one cluster, but if you do, it's available. The next thing is auto scaling. Now, the cluster that I created this with, I created it with Terraform. I could have turned on auto scaling in my Terraform code. I just didn't because I wanted to show you how this works. But you can turn on auto scaling, and not only does it say recommended here, but I also say recommended. And the reason why is because all of these cloud services, right? Like whether you're using Azure, whether you're using AWS, whether you're using GCP, they have gotten incredibly good at auto scaling. They've gotten incredibly good at knowing like, okay, I need to go up. Oh, okay, I need to go down. And it does it pretty quick, right? So there's really no reason to burden yourself with this if you're running a managed Kubernetes service in the cloud. I always say turn on auto scaling. If you see a problem with it, and if I haven't personally seen a problem with auto scaling. It does it very well. Again, it'll scale it up and it'll scale it down once the load comes back down. This is always my personal recommendation. All right. So that's how you would do it here. And then you can also set your minimum and your max, right? And if it, let's say you got a 10 node max and you're constantly hitting 9, 10 nodes, then maybe you want to go back in and see what's happening in your cluster. Okay. Now, the next thing is once you get that set up, and again, we're talking about day 2 ops here, right? Once you get that set up, you're going to need to think about how you are managing your Kubernetes clusters. Now, I don't know about you, but I don't want to go to my Kubernetes services and have 20 clusters in here and manage them all one by one. Kind of seems like a pain in the butt, right? So you want to think about an orchestration management solution. Now, you have 2 big ones, Portainer and Rancher. Portainer is very good for a few things, right? Portainer is very good if you're new to Kubernetes and you're new to containerization and you want to turn on the easy button. Rancher is really good if you already have years of experience with Kubernetes and you want a good orchestration management solution. Now, can you use Portainer if you have years of experience with Kubernetes? Absolutely, 100%. But typically, you'll see a lot of times folks are using Kubernetes folks are using Portainer if they're new to Kubernetes, or maybe they've been a sysadmin or a VMware admin for 20 plus years and they're just getting into Kubernetes. They're going to jump into Portainer. Now, in my opinion, right, I like both. I think Rancher is great. I think Portainer is great. In my opinion, Portainer has a little bit of an easier to understand UI. So that's typically why I'm going with Portainer. So if I go here, right, and I can click on my Kubernetes cluster, I can do a bunch of stuff here at this point. I can deploy applications. I can deploy and manage namespaces. I can deploy Helm charts. Let me zoom in here a bit. Again, I can deploy applications, right? And I can do this in a few different ways. I can either create from a manifest, and I can point to a manifest in my Git repo, right? Or I can use the web editor and pop it in, right? Or I can point to a URL, whatever the case may be. Another thing that I can do is I can add with form. So I can give my application name, the image where it exists, and then any stack information, including resource quotas and limits, right? So I can change my limits for my memory, I can change my limits for my CPU, and then I can give it some other information for replica counts and stuff like that. So if you have multiple Kubernetes clusters, you can absolutely do this. And the one other thing I want to show, this is probably my favorite feature here. You can turn on automatic updates, and once you click this button, you officially have GitOps. So what Portainer will do is it'll constantly look at the repo, and it'll say, okay, this Kubernetes manifest changed, and Portainer will see that and then automatically deploy the new changes from your Kubernetes manifest, much like any GitOps controller would. So really cool. You can also manage config maps, ingress, volumes, the cluster itself, and then even a lot of security pieces here. So for example, I can turn on pod security constraints, and I can have a bunch of information here for restricting running privilege containers, host namespaces, volume types, all that stuff. A lot of SE Linux capabilities here as well, seccomp, app armor profiles, a lot of the security stuff that we would be implementing for day two, you can implement it right here. All right. So really cool product. I recommend this a lot for my clients, and there's a free version. I'm on the business edition right now, but there is a free version that does a lot of this for you. Oh, and you can also do RBAC with Portainer. Now, when it comes to resource and cost optimization has actually become very popular in the past 6 months or so. I just spoke at a conference a couple weeks ago around resource and cost optimization, and it's becoming a really big thing. So there's a bunch of tools out there. One of my favorite tools that I use, again, one of the tools that I always recommend is Sosivio. And Sosivio, what it does is it gives you your resource optimization, right? So I have my cluster overview here. This is my AKS cluster it's listening to. I can go to health checks, for example, and I can see how my platform is running. I can see how the applications are running. I can go to my Kubernetes components, and I can, click on one of my clusters, for example, and any of the information regarding the cluster will be here. I can also go to insights and metrics. This is my favorite tab. And notice here, this is always really cool. Notice here how I have my namespaces, right? And I can search by memory and I can search by CPU, and it'll actually show me what's taking up the most. I don't have much here in this cluster because it's brand new. I literally just deployed it 20 minutes before I got on this call. So you can see here that there's not a lot going on, but you do have a ton of information. And if you click on real-time metrics, I can see my memory, my requests. I can see them for both requests and for limits. I can see the pods that are running, which again, I think this is really cool, honestly. I can see the pods that are running. I can see the namespace that it's in, the memory usage, the memory limits, and then I can do the same thing for CPU here. And then I can also look based on nodes, again, which is really cool. It'll tell me my memory utilization for my nodes, and it'll tell me my CPU utilization. Same thing with namespaces. So let's just say I click on, again, I don't really have much deployed here, but where is Linkerd? I have Datadog deployed here. Linkerd, here we go. Let's click on one of these, right? So I click on one of the pods, and it's going to tell me, again, all of the information about the pod ID, the UUID, the containers inside of the pod, and then any real-time metrics, memory, CPU, threads, etc. So really cool tool if you need resource optimization in your Kubernetes cluster. Resource and cost optimization is always something that I recommend for every single client, especially because I don't know if anybody on the call has gone through this already, but again, the whole FinOps thing, not to get too buzzwordy here, but the whole FinOps thing has become a huge deal for organizations, right? Like for the past 3 years or so or more, organizations have been spending a lot more money than they originally expected in the cloud. Because of that, they want to get a hold on it, and resource and cost optimization is a great place to start. So, Sysivio, I always recommend. They do have an enterprise version and they do have a free community version. So you can download it, you can play around with it. I highly recommend it. The only thing is, you want to make sure that you have at least 2 nodes running, 2 worker nodes. So the Kubernetes cluster that I'm running on right now has 2 worker nodes. Make sure that you have 2 nodes running. Okay, so next, Cast AI. Now, Cast AI is one of my favorite cost optimization tools. So again, free. Everything that I'm showing you here, by the way, there's a free version for all this stuff, right? You just gotta just Google the tool and look up the free version. There's a free. All this stuff that I'm showing you right now, except Portainer, because I have a business edition license, it's all free. So, but again, Portainer has the community edition. So regardless of if I had the business version or not, I could still show this to you for free, the same exact stuff. Right? So the cool thing about cost optimization is, well, with AI, Cast AI specifically, is you see here how like with my cluster, I can save 2.3%, $3 a month. Well, that probably won't even buy you a coffee at Starbucks, but you'll get pretty close. But an annual savings of $36.79, and I can enable that, and then it'll automatically set the resource optimization as needed, which is really cool. A lot of cool automation stuff there. So you have some cost monitoring pieces here. So like what your monthly forecast is going to be, your average daily cost, etc., per cluster, per workload, per namespace. Your node list here, it's going to show you again some resource optimization stuff. And here's where cost and resource optimization kind of gets a little bit funky. Notice here how it's like it's giving you some resource optimization information, but like even you're seeing it here too. But like that's not the purpose of Cast AI. The purpose of Cast AI is to help you with cost, right? It's going to give you some of that information here, but you'll in my opinion, you'll still need another resource optimization tool like Sysivio. Great combination, right? Sysivio and Cast AI, awesome combination. Now, 2 more things. I want to, and again, by the way, I'm going to send this Git repo after everything that I'm talking about here. I have all instructions on how to set up all this stuff. You'll see an instructions MD under all of these folders. All right. Now we're going to go over 2 more things. Let me see. I am good on time. We're going to go over 2 more things. We're going to go over Linkerd for service mesh, and then we're going to go over monitoring and observability. Now, if I just pop open my trusty instructions here, again, setting up Linkerd, I have all the instructions for you right here. I'm going to pop open the Viz dashboard. Let's see, bear with me one moment. Let's see. Maybe, let me try it here. I knew this was going to happen. Here it is. I have to set up the environment variable. Because I did it on that one. Hold on. Copy this. Let me go over here. There we go. Now it's running. So this should pop open for me. Yep. Okay, cool. So this is the Linkerd dashboard. Now, again, if you're thinking about day 2, you're going to be thinking about service mesh. Linkerd, Istio, 2 very good options. Istio is very good if you want a little bit more complex of a service mesh. Linkerd is great because it has all the bells and whistles of Istio, but it's more of like a turning on the easy button, right, so to speak. It makes things a little bit easier for you, right? So you can have this dashboard here, and you can look up your deployments. You can look up your services. Let's say I go to deployments here. I can see, I don't have anything meshed at the moment, but I can see the deployments here. And then I can also see, what has MTLS available, what doesn't. And then I can do that also based on the namespace, right? So I can see any information in terms of anything that is deployed. Good stuff. Deployments. Let me just try one thing here. I just want to showcase right here. Click on one of the deployments. It'll give you a visual of what's running and how it's running. it'll tell you the success rate of it. So Service Mesh does a few things, right? It does your encryption for you, but it also shows you your network latency and your performance, right? Any latency, circuits, etc. So you're going to see a bunch of information inside of the Linkerd dashboard regarding your pods, regarding the success rate, regarding if they're meshed or not. And you're also going to see connections, reads, writes, etc. from a networking perspective, right? So you got a lot of good stuff here. If I click on one of the pods and I scroll down, see how it says secured here? This is because out of the box, anything that's meshed with Linkerd has MTLS on by default, right? So really good stuff there. Now, the next thing that I want to show you, and again, I know I'm going through this fast because I only have a few minutes left here, but like we talked about in the beginning of the call, I am going over 3 months of work in 50 minutes. So this is I'm giving you the high level. All right. And then last but not least, monitoring and observability. Now, I feel like everybody that always does talks on monitoring and observability goes straight to Prometheus and Grafana. Great platforms, great tools. I use Prometheus and Grafana a lot. The reality is that Prometheus and Grafana, they are a lot to manage, configure, maintain, etc. A lot of the times when I'm speaking to clients, they like those tools, right? But you need a big enough staff to manage Prometheus and Grafana. So a lot of times what will happen is they'll use an enterprise tool, Datadog, New Relic, App Dynamics, etc., for the monitoring and observability. Why? Well, it does cost money, of course. However, it removes the management need, right? So instead of having to hire a couple of engineers to manage your Prometheus and your Grafana instances, you're taking that cost and you're putting it into an enterprise tool. This maybe not save you money, but save headache, right? Like save bandwidth, save overall management. Because there's a lot of tools, there's a lot of platforms, there's a lot of things we have to do when it comes to Kubernetes and when it comes to cloud. So organizations and management will often spend the money to lift that load off of engineers. Now, I'm not saying every organization, right? Because sometimes organizations instead want to overwork their engineers, right? And just say, go do it. It's fine. You can work 13 hours a day and no big deal. But a lot of organizations will want to go to an enterprise tool. And Datadog is one of my favorites. I like New Relic as well. But if I go to Datadog and then if I click on Kubernetes, we can see that I have my AKS cluster configured here, and I can see nodes, I can see replica sets. If I click on deployments here, it'll give me all of my information about my workloads, right? So again, in this case, are my deployments. So we can see here the state, we can see the name of the deployment, the cluster, we can go into the namespace, right? We can see the pods inside of the namespace. If we scroll down a little bit more, we can see some more information down here regarding if it's active, the cluster name, etc. We can also go to nodes, and then we can go to access control, and we can do a little bit of management here for our RBAC pieces. But I do enjoy Datadog because I think it has a pretty clean UI. The documentation it's good, right? It could use a little bit of work in my opinion. But the good news is like it's kind of straightforward, more or less. Like if I click on APM, it's going to tell me exactly what I need to do. I'm going to get started based on a language, and then I'm going to implement APM. So this is what you could kind of take a look at in terms of monitoring and observability. Luckily, Datadog is one of those tools where it'll give you monitoring and observability versus with like Prometheus, you have your observability and your metrics, right? I really should say metrics because in observability, you have your metrics, your traces, and your logs, right? But this tool will kind of do it all for you, right? Like you have your logs here, you can see your traces, you can see your metrics, you can see your monitoring, right? Like if you go to your dashboards, I don't have any dashboards here available right now, but you would see your dashboard. You could create a new dashboard and put in your Kubernetes cluster and all that good stuff. Right. And I am a minute over, but I think that's okay.